Good afternoon, all. Welcome to the lecture of Measure and Integration. I am audible.
Yes, sir.
Yes, sir.
In last lecture, we have started our first unit, which is a Measure and Integration. In that, we have seen first what is an algebra, sigma algebra. After that, we have defined one more definition of measurable set. That is, if suppose X be any set and curly B be a sigma algebra, then any subset A of X is said to be measurable if it is member of sigma algebra. Then the corresponding set A is said to be a measurable set. After that, we have defined measurable space. What is measurable space? What is measurable space?
The order pair X and beta, X and curly B is said to be measurable space, where X is any set and B curly B is a sigma algebra of subsets of X.
Okay. And after that, we have defined one measure. What is measure? What is measure? What is measure?
The order pair X curly beta is a measurable space. Then a
Yes.
set function mu is said to be a measure if mu of phi is equal to 0. And second condition is mu of union of countable union of EI is equal to the summation of mu of EI, where EIs are the sequence of disjoint measurable sets.
Yes. After that, we have defined measure space.
States.
What is measure space?
The triplet of X curly beta and mu is called a measure space, where order pair X curly beta is a measurable space and mu is a measure on beta.
Mu is a measure on P, and our triplet X with curly B mu is said to be measurable
Measure.
space. Sorry, measure space. What is measure space? Measure space.
Triplet na sir, X, B and mu sir.
Measure space.
If X
Triplet
and B
X
is a
curly B mu
measurable
is said to be a
space,
measure space if X curly B is a measurable space and mu is a measure on curly B.
B.
Okay, after
Yes.
that we have seen some examples on measure space. Okay, now suppose X be an uncountable set. X be uncountable set and curly B be a set which contains all subsets of X such that either A is countable or A equal to E complement where E is countable. Where this E is countable. Okay. And define one function mu. Define mu from our set curly B to closed zero open infinity. Sorry. Closed zero open infinity union infinity by measure of any set A equal to 0 whenever A is countable and equal to 1 whenever A equal to E complement where E is countable. Okay. And then we have to show that capital X with curly B and major mu is a major space. And how will you prove any space, that is any triplet X curly B mu is a major space? For that we require capital X comma curly B is a measurable space and mu is a measure on curly B, and any ordered pair X comma curly B is said to be measurable space if capital X be any non-empty set and curly B be a sigma algebra. Now here whether curly B is a sigma algebra, if suppose we have to prove this triplet is a major space, then first we have to prove that curly B is a sigma algebra. Now whether curly B is a sigma algebra, any collection of subsets of X is said to be a sigma algebra if it is closed under countable union and phi is a member of that set, whether phi is belonging to curly B. कळतंय ना?
Yes, sir.
एखाद्या ट्रिपलेटला मेजर स्पेस जर प्रूव्ह करायचा असेल तर काय पाहिजे तुम्हाला? सगळ्यात अगोदर जो तुम्ही डोमेन घेतलाय तो सिग्मा अल्जेब्रा पाहिजे ना? आहे का हे दिलेला सेट, कलेक्शन ऑफ सेट हा सिग्मा अल्जेब्रा फॉर्म करतो का? असे ए घेणार आहे तुम्ही, एक्स चे असे सबसेट घेणार आहे जे की स्वतः काउंटेबल असतील किंवा ए इक्वल टू ई कॉम्प्लिमेंट वेअर ई इज काउंटेबल. ई इज काउंटेबल मीन्स complement of A. If we take complement of A, then E complement of complement, which is nothing but E. That is E is countable. That is actually curly B is nothing but here our curly B is nothing but all subsets of X such that either A is countable or its countable or its complement is countable. Complement is countable since A complement is nothing but complement of E complement, which is E, and E is countable. That is A complement is countable. So curly B a collection of subsets of all A which are subsets of A such that either A is countable or A complement is countable. Now we have to prove that this curly B is a sigma algebra or not, and for that we require two conditions. That is curly B contains empty set phi and it is closed under countable union, and it is already algebra, that is it is closed under complement also. Okay, so first phi is countable set. Phi countable hai ka?
Yes, sir.
As phi is countable, which implies phi is belonging to curly B. Now we have to prove that it is closed under complementation, and for that we have to let A be any member of curly B, and we have to prove that its complement is member of B. As A is belonging to curly B, then its definition, according to its definition, any A is a subset of X, that is it is member of curly B if it is countable or its complement is countable. As A is belonging to curly B, then there are two possibilities for A, that is either A is countable or its complement is countable. First let us assume that A is countable. If A is countable,
Hello, sir.
Yes.
Some student wants to join the class.
Okay. Okay, now if A is countable, which implies A complement of complement. Complement of A complement is nothing but A only, A itself, which implies which is also countable. As A is countable, then complement of A complement is also countable. As complement of A complement is countable, then by again definition of curly B, this A complement is belonging to this curly B, which implies A complement is belonging to curly B. Since curly B contains all subsets of X, such that set itself is a countable or its complement is countable. As here A complement itself is countable, then it is member of that curly B. So if A is countable, then its complement is again in B. So which implies A belongs to B, implies A complement is also a member of this curly B. This is for A is countable. If suppose A complement is countable, if A complement is countable. Since as A is a member of curly B, then there are two possibilities for A. Either A is countable or its complement is countable. As A complement itself is a countable, then it must be a member of curly B. Since curly B contains all subsets of X which are either countable or its complement is countable. As A complement is countable, then it must be a member of curly B. Therefore, for both the possibilities of A, that is A is countable or its complement is countable, A complement must be a member of B, which implies curly B is closed under complementation. Curly B is closed under complementation. So to prove that curly B is a sigma algebra, we have to just now prove that it is closed under countable union. Let AI be a countable collection of elements in curly B. Okay, that is suppose A is nothing but, let A is nothing but union over I running from 1 to infinity AI. Okay, that is the countable union of elements belonging to curly B. Now we have to prove that this union is again in curly B, that is it is closed under countable union. If suppose all AIs are countable, suppose that all AIs are countable. As all AIs are countable, then we know the property that countable union of countable set is again countable. As here all AIs are countable, which implies union over I running from 1 to infinity AI is also countable. Since countable union of countable set is a countable, okay, which implies, now here we have to use the definition of curly B. Curly B contains all subsets of X such that either this set is countable or its complement is countable. As here union over I running from 1 to infinity AI itself is countable, which implies this union must belong into our curly B. Union over I running from 1 to infinity AI belonging to curly B. Okay, this is for all AIs are countable. If suppose there exists at least one AJ which is not countable, it means its complement is countable. Second possibility is, if suppose all AIs are not countable, that is there exists at least one AJ such that AJ complement is countable. Okay. Now, as here A is nothing but A equal to union, that is countable union of this collection AI, in which there is at least one AJ which is having complement is countable. Okay, as A equal to union over I running from 1 to infinity AI, which implies A complement is nothing but union over I running from 1 to infinity AI and its complement. Then by De Morgan's law, this one is nothing but A complement equal to intersection over I running from 1 to infinity each of AI complement. As here A complement is nothing but intersection of I running from 1 to infinity AI complement. And we know that if A is a intersection of intersection of I running from 1 to infinity AI, then A must be a subset of each of AI. Okay, that is for all I. As here A complement is nothing but intersection over I running from 1 to infinity AI complement, which implies A complement is subset of AI complement for all I. In that AI complement there is one AJ also, which implies A complement is subset of this AJ complement. But given that our AJ complement is countable and A complement is a subset of AJ complement, which implies that A complement is countable, which implies A complement is countable. As A complement is countable, then by the definition of our given collection of set, that is curly B, as A complement is countable, then A must be a member of this curly B, which implies A belonging to set curly B. But A is nothing but union over I running from 1 to infinity AI, and which is a member of curly B. Therefore, for both the possibilities, that is for all AIs are countable, or there is at least one AJ having complement is countable. In both the cases, union over I running from 1 to infinity AI is a member of this curly B, which implies curly B is closed under countable union. Under countable. As it is closed under countable union, then it must be closed under finite union. Countable union. Okay, as it is closed under finite union and complementation, then it must be a algebra, and this algebra is closed under countable union, and phi is also a member of this curly B, which implies curly B is a sigma algebra. Up to now, any doubt? आतापर्यंत एवढ्यामध्ये कोणाला काही डाऊट आहे का? आहे नाही काहीतरी सांगा. आवाज येते ना माझं?
Yes sir.
डाऊट आहे नाही काही?
No sir. Nice.
काही नाही. काय डिफाईन केलेलं होतं तुमचा एक सेट कॅपिटल एक्स दिलेला आहे जो की अनकाउंटेबल आहे. कर्ली बी डिफाईन केलाय, त्यामध्ये असे सबसेट आहेत एक्सचे जे की स्वतः काउंटेबल आहेत किंवा त्यांचा कॉम्प्लिमेंट काउंटेबल आहे. आणखी हा मेजर तर डिफाईन केला, त्याचा यूज तर अजून आपण केलं नाही. आणि प्रूव्ह काय करायचं आहे, हा ट्रिपलेट मेजर स्पेस आहे. हा ट्रिपलेट मेजर स्पेस कधी होईल, जर कर्ली बी हा सिग्मा अल्जेब्रा असेल तर. कर्ली बी सिग्मा अल्जेब्रा आहे का नाही माहित नव्हतं, म्हणून चेक करायचं पहिला अगोदर तो सिग्मा अल्जेब्रा होईल का नाही. मग नंतर तुमच्या दिलेल्या डिफाईन केलेल्या म्यूचा यूज होईल. तो कधी त्याचा यूज काय आहे, फक्त तो जर मेजर असेल या सिग्मा अल्जेब्रावर तर तो करस्पॉन्डिंग ट्रिपलेट हा मेजर स्पेस होतो. म्हणजे आतापर्यंत त्याचा काही यूज नाही. त्या म्हणजे याचा यूज करण्याच्या अगोदर तुम्हाला काय चेक करावं लागेल, हा कर्ली बी हा सिग्मा अल्जेब्रा आहे का नाही. कर्ली बी सिग्मा अल्जेब्रा कधी होईल, जर तो स्वतः अल्जेब्रा असेल, आणखीन तो क्लोज अंडर काउंटेबल युनियन असेल, आणखीन फाय हा त्याचा मेंबर पाहिजे. त्यासाठी आपण चेक केलं, फाय हा त्याचा मेंबर होईल, कारण फाय हा काउंटेबल आहे. म्हणजे या दिलेल्या डेफिनेशन नुसार, या कर्ली बीच्या दिलेल्या डेफिनेशन नुसार फाय त्याचा मेंबर होईल. परत आपण एक ए हा त्याचा मेंबर घेतला आणि त्याच्यासाठी दोन पॉसिबिलिटीज. जर ए हा बीचा कर्ली बीचा मेंबर असेल तर ए हा एक तर काउंटेबल असेल किंवा त्याचा कॉम्प्लिमेंट हा काउंटेबल असेल. मग ए काउंटेबल असेल तरी ए कॉम्प्लिमेंट मेंबर आहे कर्ली बीचा, आणखी ए कॉम्प्लिमेंट स्वतः जर काउंटेबल असेल तर तो ऍक्च्युअली असेलच. म्हणजे कर्ली बी हा क्लोज अंडर कॉम्प्लिमेंटेशन आहे. त्यानंतर काय प्रूव्ह करायचं आहे, फक्त कर्ली बी हा क्लोज अंडर काउंटेबल युनियन. त्यासाठी तुम्ही एक कलेक्शन घेतलं, युनियन ओव्हर आय रन फ्रॉम 1 टू इन्फिनिटी ए आय. इफ सपोज ऑल AIs are countable, then its union is again countable. Then it must be a member of curly B. If there exists at least one AJ which is not countable, means its complement is countable. That is, and as here we have taken A is nothing but countable union of these AIs, then A complement is nothing but intersection over I running from 1 to infinity AI complement. As A complement is the intersection of these subsets, then A complement must be a subset of each of these AI complement. And in this AI complement there is one AJ also, which implies A complement is subset of AJ complement also. But AJ complement is countable, which implies subset of countable set is again a countable, which implies A complement is countable. As A complement is countable, then by definition of this curly B, A is a member of this curly B. But A is nothing but union over I running from 1 to infinity AI, and which is a member of this curly B, which implies curly B is closed under countable and union, and from this curly B is a sigma algebra. Now we have to prove that the triplet capital X curly B comma mu is a major space. That is, we have to prove that we have to just check whether mu is a major on this sigma algebra curly B or not. And for that we have to check two conditions. That is, major of phi will be equal to 0 and major will be countably additive. Okay, as phi is a curly b, now case 2, that is in second case we have to prove that mu is a major on curly b. Major on curly. In that first one is nothing but we have to prove that measure of phi will be equal to 0. Okay. Now, as phi is countable, and here mu is defined as mu is nothing but measure of any set is nothing but 0 whenever that set will be countable and equal to 1 whenever its complement is countable. As phi is a countable set, then its measure will be 0. Okay. Here measure of phi is equal to 0 since phi is countable. So first condition will be proved. Now second, let AI be a countable collection of disjoint measurable sets. Okay. Now, as AI be a countable collection of disjoint measurable sets. Okay. Now, suppose that all AIs are countable. AIs are countable. As all AIs are countable, which implies its countable union is again countable. AI is countable. Okay. Now, from the definition of our measure mu, measure of A will be equal to 0 whenever A is countable and equal to 1 whenever its complement is countable. Okay, as here all AIs are countable, which implies measure of each AI equal to 0 for all I. Since here all AIs are countable and also its countable union is again countable, which implies measure of union over I running from 1 to infinity AI is also 0 since it is a countable set. Okay, which implies as measure of AI equal to 0 for all AI, then for all I, which implies summation over I running from 1 to infinity measure of AI is 0 since measure of AI will be equal to 0 for each I, and measure of union over I running from 1 to infinity AI equal to 0, as both are 0, which implies measure of union over I running from 1 to infinity AI is equal to summation over I running from 1 to infinity measure of AI. So the result will be true for countable sets, that is if AI, all AIs are countable. If suppose that all AIs are not countable, suppose there exists at least one AJ such that AJ complement is counting. Okay. Now here we have to claim that there is exactly one J such that AJ complement is countable. Okay. इथे काय आहे, प्रत्येक एआय हा काउंटेबल नाहीये, म्हणजे कमीत कमी एक तरी मिळेल एजे ज्याचा कॉम्प्लिमेंट काउंटेबल असेल. कमीत कमी एक मिळेल, पण जास्तीत जास्त किती मिळणार आहेत हे माहित नाही. त्यासाठी तुम्हाला एक क्लेम करायचा आहे, त्यामध्ये तुम्हाला तसा एजे कॉम्प्लिमेंट हा युनिकच मिळेल, आणि हे प्रूव्ह करण्यासाठी तुम्हाला अजून करावं लागेल की कमीत कमी तुम्हाला 2 मिळतील. सपोज दॅट suppose R and K are distinct integers, such that AR complement and AK complement are countable. That is, here we have to prove that there is only one such AJ such that AJ complement is complement. And for that, we have considered there are two such sets AR and AK having complement is countable. Okay, but as AR and K are distinct integers and AR complement and AK complement are that is AR and AK are distinct, which implies AR intersection AK must be 5 since they are distinct. Okay, as AR intersection AK is equal to 5 and AR union AR complement is total over given set, that is capital EX, which implies AR must be subset of AK complement. Since AR union AR complement is capital X, AR intersection AK is equal to 5, then AR must be a subset of AK complement. But AK complement is countable. AK complement is countable from this statement. Okay, as AK complement is countable and AR is subset of AK complement, which implies AR is countable. Okay, but here capital X is nothing but AR union AR complement, and capital X is given that it is uncountable. Okay, this one is uncountable, and here we get AR is countable. As AR is countable, then AR complement must be uncountable. Then only it is possible that capital X will be uncountable. But if AR complement is also countable, then countable union of countable set is countable. Therefore, RHS will be countable and LHS will be uncountable. This is not possible. And for that, AR complement must be uncountable, which implies AR complement is uncountable, which is again contradiction, since here we have taken R and K are two distinct integers such that AR complement and AK complement are countable. But here we get AR complement is uncountable, and this is due to our wrong assumption. That is, there are two such AR and AK such that AR complement and AK complement are countable, which implies our supposition is wrong. Supposition is wrong. That is, there exists, which implies there is only one such J, only one such J such that AJ complement is countable. Sorry, AJ complement is countable. Okay. Now, as AJ complement is countable, then from the definition of curly B, AJ belonging to curly B. Therefore, measure of AJ complement is countable. Then measure of AJ will be equal to 1, and measure of AT is equal to 0 for all T which are not equal to J. Since such a AJ will be unique and having measure will be equal to 1, then such a AJ will be unique. That is, AJ complement is countable is unique. Then remaining all AIs are countable. That is, all ATs are countable for T not equal to J. Okay. Then as they are countable, then according to definition of measure of AT will be equal to 0 for all T not equal to J. Okay, which implies summation over I running from 1 to infinity measure of AI. Okay, all AIs has measure 0 and there is only one set AJ having measure will be equal to 1. Then its sum must be equal to 1. Okay, now if all AIs are not countable, all AIs are not countable, then union over I running from 1 to infinity AI complement is countable. Okay, since union over I running from 1 to infinity AI complement is nothing but union I running from 1 to infinity ai complement is nothing but intersection over I running from 1 to infinity ai, sorry, here complement of whole set. Here complement of this, and which is nothing but intersection over I running from 1 to infinity each of ai complement. Okay, which implies this union over I running from 1 to infinity ai complement is a subset of each of ai complement for all I, and in that there is one j also, that is aj complement, but aj complement is countable, therefore this will be subset of that. Okay, as this one is union over I running from 1 to infinity ai complement is countable, which implies measure of this one is I running from 1 to infinity ai is equal to 1 since its complement is countable. Okay, so from this summation over I running from 1 to infinity measure of ai is also 1, and measure of union over I running from 1 to infinity ai equal to 1. Therefore, from 1 and 2, from 1 and 2, measure of union over I running from 1 to infinity ai is equal to summation I running from 1 to infinity measure of ai, and from this we say that mu is a measure on curly b, and if mu is a measure on curly b and capital X comma curly b is a measurable space, which implies the triplet capital X comma curly b comma mu is a major space. कुणाला काही डाऊट यामध्ये? आहे नाही काहीतरी?
No, sir.
There is no doubt. Then prove this. Let sequence A and be a sequence of non-negative integers, and for a subset of n, define measure of a as summation over n belonging to an, and then prove that capital N power set of n and given measure mu is a major space where capital N is set of natural number. To this one. तू करायलेत ना? Check whether power set of n is a sigma algebra or not. Whether power set of n is a sigma algebra. Power set of n means
all possible subsets of
set of natural numbers. Now,
Yes.
whether empty set is a subset of power set of n,
Yes, sir.
as
Yes.
it is a collection of all the subsets of natural numbers, then empty set must be its a subsets. Okay, that is empty set is a member of power set of n. Now, second condition, whether power set of n is closed under countable union, as
Yes,
it is
sir.
collection of all the subsets of set of natural number. म्हणजे त्या काही का सबसेट असेल ना तो त्याचं कलेक्शन आहे. म्हणजे असं जर कोणतंही तुम्ही जर युनियन घेतला तर तो काही ना सबसेटच असेल ना पॉवर सेटचा.
Yes, sir.
पॉवर सेट मध्ये बिलॉंग करेल ना, कारण तो कलेक्शन आहे प्रत्येक सबसेटचा. आणखी तुम्ही काउंटेबल युनियन कितीही घ्या यांचे सबसेट, तो मस्ट बी पॉवर सेट ऑफ यांचा मेंबर असला पाहिजे, विच इम्प्लाइज पॉवर सेट ऑफ एन मस्ट बी अ सिग्मा अल्जेब्रा. नाउ वी हैव टू प्रूव दैट mu is a measure on power set of n, since here power set of n is a sigma algebra, and for that we have to prove that measure of phi is equal to 0 and measure is countably additive. Now measure of phi is equal to, according to its definition, summation over n belonging to phi en. As there is no element in this set, then such a definition is not possible, then it must be equal to 0. Since measure of any set is either 0 or it is greater than 0. As here there is no member belonging to this set, then its measure must be equal to 0. Now here we have to prove that it is closed under countable union. Let AI be a countable collection of disjoint subsets of n. Disjoint subsets of n. That is, let us take A as a union over I running from 1 to infinity ai, and we have to prove that it is a countably additive. Okay, now measure of A is nothing but measure of union over I running from 1 to infinity ai, but from our given definition measure of A is nothing but summation over n belonging to that set A, where sequence of non-negative integers, that is an. So measure of union over I running from 1 to infinity ai is nothing but summation over n belonging to union over I running from 1 to infinity ai of an. Okay, now as here each ai is a disjoint, which implies this sum can be written as summation over I running from 1 to infinity of summation over n belonging to ai of an. Since each ai is distinct and I is running from 1 to infinity, and here also n is belonging to union over I running from 1 to infinity, that is this one is actually nothing but summation over, that is n is n belonging to a1 of an plus n belonging to a2 and so on. Okay, and this one is nothing but okay. So summation over n belonging to union over I running from 1 to infinity ai of an is nothing but summation I running from 1 to infinity summation of n belonging to ai of n. That is, as this is possible since each ai's are disjoint. Okay, but from the definition of measure, summation over n belonging to ai, an is nothing but measure of ai. which is nothing but summation I running from 1 to infinity measure of AI, that is measure of union over I running from 1 to infinity AI is nothing but summation over I running from 1 to infinity measure of AI, which implies mu is a measure on our power set of n. Mu is a measure on power set of n, as mu is a measure on power set of n and power set of n is a sigma algebra, which implies capital N with sigma algebra power set of n with our measure mu is a measure space. कुणाला काही डाऊट यामध्ये? सगळंच डाऊट आहे? आहे नाही काहीतरी सांगा. आवाज येते ना?
येस सर.
फक्त आवाज येतो की नाही म्हणल्यानंतर तेवढं सांगता याही असतं. कळतंय का नाही आता सांगा बरं का. जर परत जर असंच पुढे गेलं तर तेव्हा नाही कळालं म्हणलं तर काही उपयोग होणार नाही.
सर तो आत्ताचा पॉइंट एकदा एक्सप्लेन करा ना.
कुठला पॉइंट? हा
हा
दिले काय तुम्हाला सिक्वेन्स एन दिली. कशाची सिक्वेन्स आहे? जी की नॉन निगेटिव्ह नंबरची सिक्वेन्स आहे. आणखीन कोणत्याही सबसेट एस नॅचरल नंबरच्या कोणत्याही एखाद्या सबसेटसाठी तुम्ही मेजर कसं डिफाईन केलाय? मेजर ऑफ ए इज नथिंग बट समेशन ओव्हर एन बिलॉंगिंग टू ए एन, हे तुम्ही मेजर डिफाईन केलंय असं. आणखी तुम्हाला प्रूव्ह काय करायचं आहे? एन with power set of n and this measure mu is a measure space, and for that we require this p of n is a sigma algebra and this one is a sigma algebra. Then we have to prove that this mu is a measure on that sigma algebra power set of n, then corresponding triplet will be a measure space, and hence we will prove power set of n is a sigma algebra, and for that we require phi be a member of that power set of n and it is closed under countable union, as power set of n is a collection of all the subsets of natural numbers and empty set is a subset of every set, which implies it is also a member of power set of n also, which implies phi is belonging to power set of n. Now it remains to check that this power set of n is a closed under countable union, as it is a collection of all the possible subsets of natural number, then any union of subsets of natural number must be a member of power set of n, which implies power set of n is a closed under countable union, as it is closed under countable union and closed under कॉम्प्लिमेंटेशन. कॉम्प्लिमेंट पण परत आताच येईल ना. कोणताही सबसेट घ्या तुम्ही नॅचरल नंबरचा, त्याचा कॉम्प्लिमेंट हा परत पॉवर सेट ऑफ एन मध्येच येईल, कारण कॉम्प्लिमेंट हा त्याचा सबसेट असल्यामुळे. आणखी पॉवर सेट ऑफ एन हा प्रत्येक पॉसिबल सबसेटचा कलेक्शन आहे, म्हणजे तो कॉम्प्लिमेंट ही त्यातच येईल. म्हणजे तो क्लोज्ड कशात आहे? फायनाइट युनियन मध्ये आहे, काउंटेबल युनियन मध्ये आहे, कॉम्प्लिमेंटेशन मध्ये. आणखी फाय त्याचा मेंबर आपण प्रूव्ह केलाय. याचा अर्थ तो काय होईल? पॉवर सेट ऑफ एन सिग्मा अल्जेब्रा होईल. आता पॉवर सेट ऑफ एन हा सिग्मा अल्जेब्रा झाला. तुम्हाला फक्त चेक काय करायचं आहे? हा म्यू हा त्याच्यावर मेजर होतो का नाही. तो म्यू मेजर कधी होईल? जर एम्प्टी सेटचा मेजर जर 0 आला असेल आणि तो क्लोज अंडर काउंटेबल ऍडिटिव्ह असेल, म्हणजेच मेजर ऑफ युनियन ओव्हर आय रनिंग फ्रॉम 1 टू इन्फिनिटी AI will be equal to summation I running from 1 to infinity measure of AI. मग म्हणून तुम्ही मेजर ऑफ फाय कसा डिफाइन केला? समेशन ओव्हर n बिलॉंगिंग टू फाय an, but an be a sequence of non-negative numbers, that is it is possible from 0 to 1 up to so on. As there is no element belonging to this set, then its measure must be equal to 0, since measure of any set is always greater or equal by 0. As here there is no element belonging to that sequence, then its measure must be 0. Now suppose that AI be any countable collection of disjoint measurable subsets of n, that is A is nothing but union over I running from 1 to infinity AI. Now we have to define its measure, that is measure of union over I running from 1 to infinity AI. But measure of any collection of subset of n is nothing but summation over n belonging to an. According to this one, this is nothing but summation over n belonging to union over I running from 1 to infinity AI of an. But here all AIs are disjoint, then this sum can be also be expressed as summation I running from 1 to infinity or into summation n belonging to AI of an. Since here या सम मध्येही आयच रनिंग होणार आहे, इथेही आयच रनिंग होणार आहे आणि प्रत्येक AI हा डिसजॉइंट आहे, म्हणजे या समला तुम्ही असंही लिहू शकता. असं लिहिल्यानंतर हा म्हणजे तुमचा दिलेल्या मेजरच्या डेफिनेशन नुसार हा काय होईल, मेजर ऑफ ए आय होईल. म्हणजे मेजर ऑफ युनियन ओव्हर आय रनिंग फ्रॉम 1 to infinity AI इज नथिंग बट समेशन ओव्हर आय रनिंग फ्रॉम 1 to infinity मेजर ऑफ ए. जर हे दोन्ही सेम आले तर हा क्लोज अंडर काउंटेबल ऍडिटिव्ह झाला. म्हणजे हा क्लोज अंडर काउंटेबल ऍडिटिव्ह आहे. आणखीन हा एम्प्टी सेटचा मेजर ही 0 देतो. याचा अर्थ हा पॉवर सेट ऑफ एन वर मेजर होईल. हा जर पॉवर सेट ऑफ एन वर मेजर झाला आणि पॉवर सेट ऑफ एन हा ऑलरेडी सिग्मा अल्जेब्रा प्रूव्ह केलाय, याचा अर्थ हा ट्रिपलेट हा मेजर स्पेस होईल. ठीक आहे.
ओके सर.
खरंच ठीक आहे का फक्त परत एकदा डिफाईन केलं म्हणून माझ्या समाधानासाठी हो म्हणाले?
नाही सर, समजल्यात.
नाही कळालं तर अजूनही सांगा, कितीही वेळा एक्सप्लेन करू. ठीक आहे. इफ देयर इज नो प्रॉब्लेम देन देयर इज वन नोट. There is one definition. Let delta x of a is equal to 1 whenever x is belonging to a and equal to 0 otherwise, that is if x is not a member of a. Otherwise, then this measure is called as point mass at x. Measure is called as point mass at x. Okay, this will be actually a definition of point mass at x. That is delta be a function which is defined in such a way that delta x of a is equal to 1 whenever x is belonging to a, that is x is a member of a, and equal to 0 if x is not a member of a, that is otherwise. Okay, now let capital X curly b mu be a major space if A is a subset of B, then we have to prove that measure of A is less equal by measure of B. Measure of A is less equal by measure of B. Okay. Given that capital S curly B mu be a major space. A union B minus E. That is, if you see this by diagrammatically, suppose this one is a B and this one is A. Okay, so and this one is nothing but B minus A. B minus E. Therefore, B is nothing but union of these two sets, A union B minus A. And what is the intersection of these two sets? A intersection B minus A is equal to whether A and B minus A are disjoint.
Yes, sir.
As they are disjoint, then its intersection must be
Phi.
which is equal to phi. Okay, since B is nothing but A union B minus A, and A and B minus A are disjoint. Okay, and as A and B minus A are disjoint, then by the property of measure, measure of B is nothing but measure of A plus measure of B minus A. Okay, let us take this one as a star, which is from star. Okay, now again we know that measure of any set is either 0 or it is greater than 0. That is, measure of any set A is always greater or equal by 0. As here, measure of B is a sum of these two measures, that is measure of A plus measure of B minus A, which implies measure of B must be greater or equal by measure of A. Since measure of B minus A is greater or equal by 0. Okay, if measure of B minus A will be equal to 0, then only measure of B is equal to measure of A. But if measure of B minus A is greater than 0, then measure of B must be strictly greater than measure of A, and hence, which implies measure of A is less equal by measure of B. So, if A is a subset of the B, then measure of A is less equal by measure of B, and hence the proof. ठीक आहे, आतापर्यंत कोणाला काही डाऊट असतील तर सांगा.